Welcome to the ET380 lecture video on passive filters. Here we have a capacitor and inductor low pass passive filters. So passive filters are unpowered, and a capacitor, this will be a low pass that's put in this direction across the capacitor. Here we have going through serial through our inductor, both low pass filters where they pass low frequencies and block the higher frequencies. Here we have a capacitor and an inductor high pass passive filters. We have a serial through our capacitor, output across our resistor. Here we have our resistor with our output across our inductor. Both high pass high frequencies and block lower frequencies. Here's a low pass L-type filter where we have an inductor and capacitor, and it's from its L shape, and we use in both components. Here's an L-type high pass where you have the capacitor serial and parallel across our inductor. Here we have a low pass pi type because it's shaped like the pi symbol. So we have capacitors and one inductor. Here we have a pi type high pass passive filter, again the pi shape, with two inductors and one capacitor. Here we have a T-type low pass capacitor filters where we have two inductors, one capacitor, and it's named for its T shape. Okay, here we have a T-type high-pass passive filter where we have two capacitors and one inductor and the T shape. Here we have a pi L-type passive filter, and it is two L networks connected back to back. We have two inductors, two capacitors, and a balancing resistor, which we call a virtual resistor. And this one is used for 50 ohm balancing of an antenna with a tube type amplifier used in radio transmitters. Here we have a constant K passive filter where we're trying to make it respond to different frequencies by utilizing capacitor and inductor components, and it's supposed to be independent frequency. It's simple, and it's been replaced by more accurate methodologies in modern filter design. And from the FCC, it has high attenuation of signals at frequencies far removed from the pass band. Here's an M-derived passive filters. We have a T section and pi section, and they have a combination of these, and we have a formula based on M, and it's supposed to be an improvement over K type. And according to the FCC, the filter uses a trap to attenuate undesired frequencies too near cutoff for a constant K filter. Okay, here we show different filter types response. So these are the response curves. So we see elliptic, and we get some ringing, so they're not very accurate. In the pass band, it does have a steep roll-off. The roll-off is how steep it is. And we have the Shub says, which is also ringing, and so it's not as good a filter. And we have a Bessel feature, which is flat and then has a reasonable roll-off, and a Butterworth has a pretty steep roll-off and it's flat. And according to the FCC Butterworth filters, it has a maximally flat response over its pass band.